Based in Santa Clara, California, Colovore is the leading provider of colocation solutions for the deployment of high-performance computing infrastructure.
When we sat down to write a business plan, we decided we were going to look at the industry based, through the lens of the end user. The folks that are, not the people that are signing the contract, but the people that are working in the data center. Instead of leading them, we just said, what are the things that frustrate you about doing business in your current colo situation, and what would you like to see done differently? There's no one thing that ended up being like just big and glaring, but if you put 5 of them together and you can solve 5 of those things, then it really does change the experience. Yeah. The folks that had been doing colo for the past 20 years, they recognized it immediately. And you could tell they really appreciated what we were trying to do. But because of the HPC thing that's coming at us and the AI stuff, they got started in the cloud. And then when all of a sudden you need to quadruple your GPU cluster, all of a sudden the price point is just through the roof.
Couple of bills.
They start looking at, acquiring equipment and putting in a colo. So those are kind of the two groups we were speaking to, but luckily what we were doing spoke to both of them for different reasons. Phase 1 we built to a 20 kW per rack standard, and then phases 2 and 3 we bumped that to 35, which is the maximum of the rear doors. And our entire, I'll give you an idea, our entire phase 2, which is 1.5 megawatts of UPS, the average across that phase is 20-something kW.
Right.
Now with this, the HPC type of workloads, you could stand in front of the UPS and you could literally watch as clients rev up and down jobs, rendering. You can watch the UPS swing by hundreds of kW.
With 35 kilowatts of power and cooling capacity in every cabinet, Colovore's data center is optimized to support customers with applications that are both data and speed intensive, such as private and hybrid cloud, big data, artificial intelligence, machine learning, and Internet of Things applications.
Peter's become, he's been studying up on the AI thing, and now kind of, using those tools, to see if we can't do some predictive stuff here in the data center as well. So it's kind of, our clients have kind of inspired us to get involved in this as well, which is really kind of fun.
Quite often people start thinking about doing machine learning related to some of the aspects of like improving the efficiency of a data center. And that has been getting a lot of coverage from Google, for example. But one of the things that we also want to try to do is to try to use machine learning to predict failover loads across panels throughout the data center, and to try and predict what our loads are going to be within 24 hours, so that we can start talking to our customers and tell them that they need to start reducing the power load on their machine learning activities. And in most data centers, they have a lot of space and not so much power. And in our particular case, we have a huge amount of power with very little space.
So you have to optimize that.
So we have to optimize it. And so how do you do that? We use the DCD doors so that we can get that power in the racks and have the cooling abilities.
Even in 2012, there were multiple products out there, but the chill off was definitely a big inspiration for us. Because we wanted to go dense. We knew 20 was kind of the starting point, and some people thought that was crazy in 2012 to target 20 kW a rack, but we knew that it was going to keep going. Some of the products we looked at, I think they work well, but like for instance, some of them had like rubber hoses that swung with the door,
or door hinges also,
rather than the internal hinge. And so that was, the durability of it was a really, really huge consideration for us.
We really tried to see how we could find something that would be as robust as possible for the environment that we had. And we could not take chances. And it was very important for us to have passive doors, because we saw other solutions in which they had active fans on them with up to 6 fans per door. When you're talking about 400 cabinets, that's 6 fans each. You're talking about thousands of fans, mean time between failure, the fan noise, all of those sort of aspects. How do you actually get power to the fans in addition to it? How does that affect our PUE? And our PUE for us, in many data centers, a PUE is just an add-on cost. For us, PUE is a key aspect of our profitability. And because we charge on a fixed rate per kilowatt consumed, irrespective of what the PUE is. And so therefore we need to drive that down as much as possible.
And we just decided we want to try to keep things as simple and straightforward as possible. And we made a good decision. It's just worked really well. The floor, what's different here is that we can do this in every single rack in the data center. We have distributed the power and the cooling so that we can push these densities in every single rack. And in existing data centers is that you get demand for density, and so your anchor tenants, they're the ones that you feed with the additional capacity. But then you end up creating these high density islands. We live through that. So what's really fun about this is that we don't have to second guess. We've standardized on power distribution. We've standardized on everything. You walk out there and it's uniform and it's clean.
There's going to be a need to have data centers that are very, very high density in urban cores across the world, not just the United States, but everywhere. So you're going to find these sort of data centers not necessarily in places that you'd normally expect them to be, but they'll be in areas in a city that has seen an abandonment of light manufacturing. Not necessarily 120 megawatts, but 2 megawatts or 3 megawatts. And data centers like ours being put inside facilities like that so that we can provide services to the end consumer for that particular metro.
That is the edge, right? I mean,
it is the edge.
Literally.
But one of the things that you hear about when you're talking about the edge all the time is that people are saying, yeah, we can do it, but it's like 4 to 8 kilowatts per rack. What I'm talking about is 35 kilowatts per rack at the edge, everywhere. And so therefore, to try and shoehorn a legacy solution into the metropolitan area as close as possible to the end consumer, it's not going to work.
Our approach will stay the same. The way we got here was listening to the end user. And now we've got a customer base of folks that are really pushing these new technologies. So as long as we can take good care of them, they grow with us here. Hopefully with our relationships, we'll have an idea when this stuff starts to push out across the country and around the globe.